Hi, everyone. Our project is on the Iron Workers Memorial Bridge, formerly known as the Second Narrows Crossing. On June 17th, 1958, the Second Narrows Bridge collapsed that was being built across Burrard Inlet in Vancouver. While under construction, two large pieces of the bridge collapsed, resulting in dozens of the workers falling into the Burrard Inlet. This bridge collapse is known as the worst industrial disaster in Vancouver's history. The Second Narrows Bridge provided access for cars and training, but the pivoting section that raised and lowered, allowing ships to pass through, was hit multiple times. The Pacific Gatherer got wedged under the bridge and ripped away the bridge's center span. Once rebuilt, the span 5 began to crash into the inlet. The momentum dismembered the columns of Pier 14, resulting in span 4 to lose its grip and collapse into the sea. The engineer working on the span 5 design made many errors that were not caught by the engineer in charge.
So why did this happen? The bridge collapse can be attributed to a miscalculation by bridge engineers, so that's human error, as well as questionable steel quality and some lax engineering practices. Some immediate causes would be the procedures, the non-application by individuals and groups, human error, so a mistaken action, and workplace environment layout, unprotected height and congested or restricted motions. Some root causes are some skill level, so infrequent performance of skill, contractor selection, lack of contractor pre-qualifications, engineering, designing, and commissioning, so inadequate assessment of design risks, planning, inadequate skills identified, and risk management, inadequate hazard identification. If we look at the James Reason model, it explains the occurrence of system failures by comparing it to an image of Swiss cheese. When risks are identified, these Swiss cheese holes may be open as it's a risk and then closed when the risk has been mitigated. Sometimes though, when all hazards and risks, all Swiss cheese holes are aligned, this results in the risk and hazard reaching the worker and most likely causing harm. In this case, all of the holes must have been lined up for the hazard to have occurred and resulted in so many losses. If we also look at the James Reason model, there were barriers that were in place. So the team had placed a false work pillar that was intended on supporting a piece of the bridge throughout the construction. And since the junior engineer did in fact make a miscalculation, senior workers should have been checking his work to ensure that no calculations were missed. Some of the failures were many ships had hit the bridge that can cause wear and tear and add to the holes in our Swiss cheese model that may have caused the perfect storm when the bridge did collapse. Additional hazard assessments should have been done, documenting the severity of the wear and tear that occurred due to the ships.
What was the impact of the accident? The immediate impact was the loss of the lives of 19 workers, including that of 14 iron workers, 3 engineers, and a painter and a diver. Wastage of material used for construction, collapse of the bridge into the river affected the environment in a very negative way. The root cause of the accident was improper design and calculation of load on the beam. This led to the overload on the structure that had a badly effect on the entire process. There is severe damage that had occurred from a locomotion to locomotives and cranes used for the work site. What was the impact in the long term? Property damage, financial loss, impact on families and victims and visitors, legal issues, and loss of the reputation in the company.
So now let's have a look on what has been done in the industry to prevent this from happening again. So a massive spout shine project was implemented. New bridge was completed and opened in August of 1960, built adjacent to the original one. Ministry of Transportation and Infrastructure contractors began to work, refurbish, paint, and protect the steel beams. Focus was on the structural maintenance work, relocation of the beam to protect from corrosion, and minor steel repairs such as replacing rivets and balls. The contractors built movable containment scaffolding that attaches to the bridge and preventing any contaminants from falling into the second narrows below, which means proper safety measures has been taken for avoiding the reoccurrence of the accident. This project is means to ensure that the new bridge will stand solidly for several more decades before replacement. Ministry says with proper maintenance and regular rehabilitation, the bridge should have 45 years of service. So the involvement of employer, management, and the supervision. So the employer has appointed safety officer to improve the safety standards. Adequate number of tools and machineries are provided for workers. Then adequate number of employees are hired for doing each task. And from the management level, weekly safety meetings are carried out. Proper personal protective equipment was provided. Proper training was given to each employee and staff. Then proper rest breaks and working hours was provided. And about the supervision, a supervisor was present on the site for every 10 workers. Then proper order was followed for each task.
For the indication of the internal responsibility system adoption, there should have been proper risk assessments done before each workday or new project. There were errors made that were not caught, showing that the work was not inspected properly. They seemed to be compliant of following the right procedures at the time of the event, but there was not a lot of information about the IRS that we could find, so we can only assume about most things. Corrective actions and learnings. Given that the temporary arm holding the fifth anchor span was deemed too light to bear the weight, the bridge engineers should have ensured that temporary arm could hold far more weight to account for any potential changes. They could have potentially avoided this by doing more frequent inspections, regular maintenance checks, and risk assessments. So for corrective and preventative measures from the company, the event of inspections, the corrective action was daily inspections and daily toolbox talks reviewing safety measures. And the learnings were they were having weekly safety meetings at the time, but could have benefited from more frequent meetings. The company was following proper protocol at the time of the event. For the event of regular maintenance, the corrective action was regular maintenance on all tools being used on the bridge. This includes cranes and mechanical vehicles and equipment. The learnings were that the company was doing regular maintenance at the time of the incident. For the event of risk assessments, the corrective action was risk assessments should be done weekly to check on the risks associated to all areas and crews working on the bridge. And the learnings were that the company was doing regular risk assessments at the time of the incident. The event of not being tied off, the corrective action was that workers could have been tied off, and the learnings were that more workers could have potentially drowned by being tied, and the company was following health and safety measures at the time of the incident.
Are there any questions before we finish off?
All right. So closing thought, if anybody knows a structural engineer, you may have noticed that they wear a steel ring on their pinky finger. And the reason being is every time they place their hand onto a piece of their pen to paper, that ring is supposed to click. And that click is supposed to remind them that every time they write something down, they are taking the lives of other people in their hands. And this incident shows that perfectly, how one small mistake in calculation by an engineer can lead to a devastating loss. So not something to be taken lightly, that's for sure.